Hi, I'm Udoini, a Mac UI frameworks engineer, and this is Modernize Your AppKit app. A modern app takes advantage of how AppKit interfaces with Mac, so that its form and function feel in harmony with the rest of the system. That harmony shows up in 3 places: in how people drive your app, in how the system manages it, and in how it looks and feels on the screen. Today, I'll share tips for all 3. I'll begin with modern precision input methods that your app should adapt to. Then, I'll discuss the importance of preserving continuity across launches. That is, how your app can terminate gracefully when the system needs it to and come back to where it was left off. And finally, I'll go through updates to the look and feel in macOS 27, many of which you'll notice without having to rebuild your app. I'll start where the Mac started, at the input device. Precision input devices have been at the heart of the Mac since the very beginning. The first Mac shipped with a keyboard and mouse. Over time, the APIs for handling these various kinds of input have evolved and become far more convenient. Mouse down and tracking loops have been the go-to pattern for implementing interactive behaviors in AppKit apps. However, AppKit isn't the only framework on Mac. SwiftUI, UIKit through Mac Catalyst, and AppKit work together to create the Mac experience. They rely on gesture recognizers to provide a common event handling language across all 3 frameworks. Gesture recognizers empower AppKit to provide advanced behaviors without having to build that yourself. The modern way of dealing with events is gesture recognizers. I'll explore 3 solutions that interface well with them: view-based APIs, control events, and custom gesture recognizers themselves. These offer the same customizability as tracking loops and mouse down overrides, and support cross-framework compatibility. I'll tell you when to reach for each. Common mouse down overrides enable tracking selection, showing context menus, drag and drop, and text selection. If you're currently overriding mouse down, AppKit has dedicated APIs that handle these behaviors more reliably and take full advantage of the modern Mac platform. Mouse down is often overridden to track selection. Instead, observe the selected property on types like NSCollectionViewItem and NSTableRowView. Or use delegate callbacks that are notified when selection changes, like NSTableViewDelegate and NSOutlineViewDelegate. To show context menus from a view, you have a few options. Use the class property default menu on NSView, where all instances of the view will show the same menu. Use the instance property menu on NSResponder to provide a different menu for every responder. Or use the instance method menuForEvent on NSView to dynamically create the menu based on the event. If your app uses collection container views, use modern dragging delegate methods like TableView pasteboardWriter for row. Create a pasteboard item, set the data on it, and return it. Similar methods exist on NSCollectionView, NSOutlineView, and NSBrowser. If you need text selection behavior outside of NSTextView, use NSTextSelectionManager. It's a new API in macOS 27 that takes advantage of gesture recognizers and brings classic macOS text selection behaviors to any view. Attach it to a view and set up a text selection data source. You'll then have support for bidirectional selection, drag and drop with text, toggling, and much more. The next solution might seem a little familiar if you know control events from UIKit. Control events are now in AppKit. Control events can be added to standard Mac controls, like buttons or sliders. They enable your code to react to user-driven tracking state changes rather than having to implement complex mouse-down tracking logic. AppKit calls a registered target an action when the control event is triggered. Most of these control events have been made available from OS 10.11. Here's an example of NS control events. Instantiate the button and register a target in action for a control event. Note that you don't even have to subclass NSButton to get this to work. For more control over interactions in your views, add standard gesture recognizers. For even more flexibility, create your own gesture recognizer subclasses. Learn more in the gestures documentation. Because gesture recognizers operate on a view and its subviews, overlapping sibling views can silently block mouse events. If a control doesn't seem to be responding to a click, make sure you don't have some sibling view that overlaps that button. To address this issue, resize the view so it doesn't overlap. If the view should not be resized because it's an overlay, override hit test and return nil, so hit testing can fall through to the content underneath. Now, I'll focus on keyboard navigation. Your app needs to respond to keyboard input seamlessly to enable speed and accessibility. Keyboard navigation for controls can be turned on in system settings. When it's on, focus moves between controls using Tab or Shift Tab. The key view loop is the order in which controls are cycled through when the Tab key is pressed. To automatically recalculate the loop every time a view is added or removed in the hierarchy, enable Auto Recalculates Key View Loop on the window. If you do not set this value, you are in charge of creating and maintaining the key view loop. Keyboard navigation also reaches beyond your app's windows, into the menu bar and status items. Navigating across status items is a little different from main menu items. Status items that show a menu when clicked already behave like menus on the menu bar. But status items can also be triggers for actions or display some kind of transient UI. To trigger an action, modify NSStatusItem's button property to include a target and action, and optionally an image. This behaves like a regular button, and the action fires automatically when return is pressed during keyboard navigation. To use a custom view for your status menu item, use StatusItem's view property to set the view. Then, add a target and action to the status item to enable performing that action. Status items can also be triggers to show custom windows, for example. When a status item shows its window, AppKit needs to know when that UI is active, so that keyboard focus can behave correctly. Track the lifecycle of your custom UI using the Expanded Interface Session API. First, set a delegate when the item is created that will receive begin and end calls to display or dismiss your window. In the delegate, implement status item did begin expanded interface session and status item did end expanded interface session. These methods are called by AppKit to manage the lifecycle of an expanded interface session. In the did begin call, show the window. In the did end call, order the window out. When it is time to dismiss the session, for example, because an action has been selected, call cancel on the expanded interface session. Note that the session might be canceled for you if focus naturally moves somewhere else. SwiftUI menu bar extras do a lot of this work for you. Check out the WWDC26 video, Use SwiftUI with AppKit and UIKit, to learn how an AppKit app can use a SwiftUI menu bar extra. Making sure your app works just as well with the keyboard as with a mouse is especially important for the many power users who choose the Mac. Providing a seamless transition within and outside of your app is one more way to enable them. Speaking of seamless transitions, a great Mac app seamlessly quits and quickly restores. It quits without pushback and comes back as if it was never quit in the first place. People should be able to quit their apps at any time, sometimes because they want to, sometimes because the system needs to reboot, which might happen during an overnight software update. So your app should only block quit when it genuinely needs to. When your app is presenting a sheet, the window might not be able to close. And when a window can't close, the app can't quit. The NSWindow property prevents application termination when modal defaults to true, and for good reason. It's important to make sure your app doesn't lose data when a document needs to be saved, for example. Set this property to false for all modals or sheets that don't strictly require intervention to allow more graceful application termination. With graceful termination handled, The next step is restoration. Use NS Window Restoration to customize how your app comes back. State restoration requires 3 steps: opting into state restoration, encoding the UI state, and decoding the state to restore Windows and UI. I'll go through some code that uses NS Window Restoration. First, set an identifier for the window on the window controller. For common windows, like your main window or a preferences window, set an autosave name. This helps restore your window to an active space with the same frame. There is no need to set an autosave name for document windows. Then, ensure window.isRestorable is set to true, so AppKit can call encode restorable state and restore state on your windows. This also lets AppKit automatically restore window state, like which window was minimized, which one was frontmost, and which was full screen. Also, set a window restoration class, which will be invoked when the app is relaunched to restore the window itself. Use encode restorable state to preserve everything you need to recreate your Windows state. Call Super's implementation as well, so your state is restored correctly. In this example, the selected items identifier is encoded with the product identifier key. Avoid encoding data that lives in your document or database. The goal of state restoration is to be able to reconstruct the state of the UI, not to reserialize the whole app. All NS responders have an encode restorable state method that you can override, so manage state for your views as well. Encode restorable state is only called when state for the object has been invalidated. Every time there is a change to your view hierarchy that should alter the saved state, call invalidate restorable state. In this example, this method is called when a different product is selected in the sidebar. At a later time, encode restorable state will be called on everything that was invalidated. That's what your app needs to save the state of its UI before it has quit. When the app is relaunched, you'll need to decode all that information to restore the UI. First, restore your windows, and then restore the state on those windows. In the window restoration class, implement the method restoreWindow_with_identifier to recreate the windows in your app. This method is called for every window that's being restored. Its parameters include the Windows identifier and the completion handler that needs to be called with the corresponding window. Using the identifier, recreate the window controller and windows. The main window is already available on the app delegate's main window controller. Call the completion handler with the existing window. For other windows, instantiate the window controller and pass in its window to the completion handler. If window creation fails, still call the completion handler with the error. AppKit waits on every restorable window, so always call the completion handler. If you can't call it from within this method, save the handler and call it later, but be absolutely sure to call it. Once the windows have been restored, the last step is to restore the UI for each window. In the window controller's restore state method, AppKit will hand you the same coder object containing the keys you encoded before. This is the place to fetch any data required to reconstruct your app state. Decode the identifiers and hand them to the corresponding view controllers. When you're done, your windows should be in the same state as before. Enhancing quit and relaunch to feel uninterrupted helps people pick up right where they left off, whether they quit the app or restarted their Mac. To learn state restoration in practice, check out the code sample, Restoring Your App State with AppKit. With input and restoration in hand, there's one more area where your app and the Mac meet, the UI. The liquid glass material introduced in macOS 26 continues to evolve. Your app will benefit from many of the updates automatically. If you adopted liquid glass in macOS 26, your app will pick up a few changes when you run it on macOS 27. The automatic NS scroll edge effect style resolves to a hard edge effect when there is free-floating text, like the window title in the title bar. Sidebars extend to the window's edges. Selection in the sidebar uses a semi-bold text style for emphasis. And content still flows behind them. Bordered toolbar items over the sidebar adopt liquid glass as well. New in macOS 27, there is an effect that can be added to glass, where the glass subtly bounces when clicked, giving a sense that the control is responding to the interaction. Maps uses this for some of their custom controls. This would not apply to all uses of glass in your app. Use this effect with controls and buttons or a glass container of interactive controls. A little goes a long way. Rounded rectangles have been a signature of the Apple ecosystem for decades, from hardware bezels to controls and containers across macOS. AppKit has new API for concentricity. Content meant for the corner can adapt the shape of its container instead of feeling at odds with the rest of the window. For example, the local weather view in Maps is concentric with the window. When a view sits near the corner of its container, its own rounded corners should follow the curve of that container. The closer the view is to that container's corner, the more its radius should match. To make your button or view concentric, use the Corner Configuration API. First, create a custom view subclass. On the custom view, override Corner Configuration to return an NSView corner configuration. For the radius, use Container Concentric on NSView corner radius. This calculates a radius based on the container view. Set a minimum value as well, so that every corner is always rounded. You can choose from many different kinds of factory methods for the configuration. To maintain a rounded rect with the same radii across all 4 corners, use uniform corners. These are a few pointers that can help make your app harmonious on modern macOS. I'll leave you with a quick recap of where to start. Identify places in which you are overriding mouse down in your app, and instead use view APIs, control events, or gesture recognizers. Prioritize user intent over tracking loops. Make sure your app works just as well from the keyboard as from the mouse. Make quit and relaunch feel seamless, so your app picks up exactly where people left off. And evaluate your view hierarchies to adopt concentricity in views and buttons. Thank you so much for watching. Whether your app is for the students at school learning how to use a computer, or the power users who build some of the world's most important tools and art, your apps have played a central role in this experience. Keep on creating.